from an architectural point of view, the main design concept was to create a fully transparent crystal to complete the Luxottica headquarter in the heart of Milan. It's a kind of a secret icon which is not visible from the street, actually in the middle of the existing garden of Palazzo Litte. The really clean cut forms, the cutting-edge solution, and the material selection give to this architecture an expression of innovation, beauty and functionality, starting from the glass facade. So the really high technological glass facade is a balance between reflection and transparency. It's really similar to, a filtering protective lens, like the ones which are actually manufactured by the client, who create a connection, like a physical contact between inside and outside, still ensuring proper environmental condition outside and giving a really good interaction with the existing Palazzo Litte. As at the beginning, the main concept was to have a fully transparent crystal with a good balance between reflection and transparency, and also achieving this connection between inside and outside. So it was clear from the beginning that the double skin facade was one of the best choice to achieve this goal. And I still think that when we think about fully glass facade, double skin facade is really a good option because it really permits you to balance between the architectural concept and the high performance of the building. So it still represents a valid solution because if designed properly, you can really push the design of the inner wall, which is actually the thermal and the weather barrier, and leaving actually to the external facade only an aesthetical function, which can also help to improve the overall energy performance. So one of the main challenges was to get the optimal compromise between the architectural concept of having a fully transparent building, at the same time achieving a really high performance in terms of energy performance, solar control, and also proper thermal indoor environmental condition. It's clear that the high quality of the transparent glass was the real must. So, and this has been achieved through a proper selection of the material, of the glazing, of the coating, and also through a really strict specification criteria during the production of the glass in order to minimize any visual distortion during the heat treatment, like local and global distortion and otherwise. The other challenge was to really minimize the impact of any framing. So the inner wall in the inner facade is actually made of glass mullions. Instead, if we look at the external facade, actually you have just horizontal metal profiles. You don't have any vertical support. So this could really ensure the maximum transparency. So the main facade features a double skin facade, which is actually a passive, externally naturally ventilated double skin facade. So during the winter periods, of course, it creates a kind of thermal buffer in order to reduce the heat loss and so provide the additional thermal insulation. Instead, during hot periods with the solar radiation, the shading device within the cavity actually provides the solar control, while all the heat absorbed within the cavity is actually removed through the natural ventilation to outside. And this is really important, especially when you design double skin facade, having the control of especially during hot period, in order to avoid the cavity overheating, which can lead to unwanted additional heat gains. So when you design a double skin facade, it's really important to properly model the double skin facade. Steady state analysis were carried out through proper software in order to simulate the ventilation within the cavity, the solar control of the shading, and that was done actually also modifying different parameters like the characteristic of the glazing, the property of the shading device and the type of shading device, also the size of the cavity for the ventilation. After a CFD simulation was actually run, and in order to properly modeling the environmental condition within the cavity, so the real distribution of temperature, the airflow, and all this also was to confirm the first analysis made through a steady state simulation. So the maintenance strategies have been actually implemented and studied since the beginning of the design, actually, in order to provide an integrated solution between architecture and building operation, and also considering the particular context where the building has been built, which is an historical garden in the center of Milan. So, from a practical point of view, the access and cleaning of the external facade can be carried out directly from outside and from the ground. Instead, the access and cleaning of the inner facade is actually done within the cavity through a rail system which is installed at the top of the cavity with the safety lines and roof access technique. So usually a double skin facade, the access within the cavity is usually guaranteed through metal walkways. In this case, there are no metal walkways because as said at the beginning, the purpose was to have a really fully transparent facade. The reglazing of the inner facade is done by removing, the panels of the outer skin, and so providing direct access to the inner wall. All the components of the facade are made of high quality materials coming from a meticulous selection of glazing, low iron content of glazing, selective coating, specific control during the also fabrication of the glazing in order to minimize any visual distortion. Also, the glazing at the ground floor is a 7 meter high panels. So you can imagine that, handling and installing such high value and also expensive materials within an existing courtyard where there are existing building, existing trees with a really limited space for the storage was really challenging in order to ensure the construction quality.